Limit comparison test. Suppose a sub n is greater than 0 or positive and b sub n is greater than 0 or positive. And the limit as n approaches infinity of a sub n over b sub n is equal to L and is both positive and finite. So in other words, when we do the limit of a sub n over b sub n, we get a value that's positive and finite. And finite meaning we just get a positive number. Then the two series a sub n and b sub n, they either both converge or they both diverge. Let's try examples here. Determine whether the following converge or diverge. In example A, we have 1 over 3n squared minus 4n plus 5. We're going to compare that to n equals 1 to infinity of 1 over, let's go with 3n squared. And this one converges by p-series. So we've established that the one we're comparing it to converges. Now let's do the limit comparison test. We have the limit as n approaches infinity of a sub n over b sub n. We have 1 over 3n squared minus 4n plus 5, and then over 1 over 3n squared. Well, if we multiply the top and bottom by 3n squared, we get the following. The limit as n approaches infinity of 3n squared over 3n squared minus 4n plus 5, because these will cancel, and then 3n squared times 1 is 3n squared. This is equal to 3 over 3, which is 1. And 1, we say 1 is finite and a positive value, so positive. So the series converges by the limit comparison test. In example B, we are going to compare this one to n equals 1 to infinity of, how about 1 over 4n? 1 over, we could even do, we don't have to do 4n, we can just do 1 over n. And this one diverges. Diverges, it's the harmonic series. Harmonic series. Then we'll do the limit as n approaches infinity of a sub n, or our first one, n to the fourth plus 10 over 4 n to the fifth minus n to the third plus 7 divided by what we're comparing it to. This is the b sub n, and then multiply the top and bottom by n, which is the limit as n approaches infinity of, we have n to the fifth plus 10n over 4n to the fifth minus n to the third plus 7. And that's equal to 1/4, which is, and then we say 1/4 is finite, in other words, a number, and positive. And since what we're comparing it to diverges, we say diverges by limit comparison test. For letter C, we're going to compare this to the sum as n goes from 2 to infinity of 1 over n to the third, which converges by p-series test. And then we'll do the limit as n approaches infinity of 1 over n to the third minus 2 over 1 over n to the third. And then we can multiply the top and bottom by n to the third, and we get limit as n approaches infinity of n to the third over n to the third minus 2. And that's equal to 1. 1 is finite, in other words, not infinite, and positive. So the series converges by the limit comparison test. Direct comparison test. If A sub n is positive and B sub n is positive, we have 1. If B sub n converges and A sub n is between 0 and B sub n, then A sub n converges as well. If A sub n is always below B sub n, and B sub n is decreasing fast enough to converge, then A sub n must be decreasing fast enough as well. So here we have if A sub n is always below B sub n, and this one's decreasing fast enough, A sub n must be decreasing fast enough as well. Number 2, if A sub n diverges, and A sub n is between 0 and B sub n, then A sub n is forcing B sub n to diverge as well. Example, determine whether the following converge or diverge. Let's compare this to n equals 1 to infinity of 1 over n to the third. Now, because the denominator is fairly simple, we can state that 0 is less than or equal to, this is a bigger denominator, so it'll be a smaller value. N to the third plus 1 is less than or equal to 1 over n to the third. And 1 over n to the third, it converges by p-series. So the original converges by direct comparison test. By direct comparison test. For this one, we're going to compare this to n equals 1 to infinity of 1 over 3 to the n. This is a geometric series where r is equal to 1/3, which is less than 1. And this one converges by geometric series. We can also make the statement that 0 is less than or equal to 1 over 3 to the n plus 2 is less than or equal to 1 over 3 to the n. This will be a slightly larger denominator, which makes a smaller value. So this one converges by direct comparison test. For letter C, we're going to compare this to n equals 4 to infinity of 1 over n to the 1/2, or 1 over square root of n. And this one diverges by p-series test. And we can say that 0 is less than or equal to 1 over the square root of n is less than or equal to 1 over the square root of n minus 1. This denominator will be smaller than this one, this denominator will be larger than this one, which makes this a smaller value. Now, if this one is diverging, it forces our original to diverge. So diverges by direct comparison test.